Hello, everyone, and welcome to the presentation on local motorcycle dealership, where we will talk about the database design and its implementation. So, for the local motorcycle dealership, they basically want a catalog and a pricing, a view where they can insert the data into these tables and can manage it, the customer and its history, along with the warehouse, where the warehouses are located, and the inventory that is present in the warehouse, the loan and insurance. So, what are loan providers and insurance providers that are available at the local dealership, along with the ordering where a customer can have a shopping cart experience. And further, the main is the dashboard where they can identify what all vehicles need to be given to customers today, which have been booked previously, as well as the reporting on how much sales has been performed today, how many, or in the past, or which salesman is doing the most number of sales every day. So, in the first phase of the database design is a conceptual modeling design. In the conceptual modeling design is basically the broad view of the database system, which includes the model set, identifying all the entities and the relationships, which are basically the nouns and the verbs in the business requirements. And all these entities and relationships, and then are added into an entity relationship diagram. But before that, to identify the relationship, there is a way of identifying all these by creating a table with all the entities in the as mentioned in the rows and columns in the table one, and then identifying all the relationships. For example, customer purchases a vehicle, and there is no relationship between a customer and a customer, but insurance can belong to a customer. Similarly, all these relationships are identified using this table format structure. As you can see here, this is the entity relationship diagram, with all the relationships identified have been marked in the rhombus shape, and then all the entities are in the rectangular shape. And also, you can see the vehicle model, employee, loan catalog, insurance catalog are all kind of the catalog details tables, which are the unique data and do not contain any customer or specific physical data. Further, vehicle is the actual vehicle which has been marked, and vehicle model contains the unique information about that particular vehicle. So vehicle is identified by vehicle model, and vehicle model belongs to only vehicle. It does not belong to any other entity. And the next step in the database design is a logical modeling design, which basically that has a three aims for the design. That is finding the data that is contained in the database, the relationship between various entities, and like relationships for one to many or one to one, many to many, and similarly the constraints on the data, whether the data can be null or whether the data can be derived from the other tables. For mapping, the entities are directly marked as tables, the association as relationships, and attributes to columns, and data integrity and limitations are identified from these constraints. So here you can see the entity relationship diagram that have been derived from the logical modeling. We have identified all the column names that are present for that particular table, and model identifier is basically the primary key for that vehicle model. Similarly, you can see we have in vehicle the model identifier as a foreign key from the vehicle model. Then we have the warehouse ID from the warehouse table, order ID from the order table, when the order ID will be populated only when the order has been sold, so it can be null, and similarly to customer ID. So these are all kind of foreign keys and primary keys, that is the constraints that have been identified in the logic model design. And then you can see there is a one-to-one mapping and one-to-many relationship between a variety of tables. Let's go over to the next slide. So in the relational schema, we basically define a schema for the local motorcycle dealership. You can see here, this is SQL syntax for creating the schema with the user LDMS. It's a short form for local dealership motorcycle. And similarly, once a user has been created, the DBA needs to give all the permissions over creating tables, procedures, and SQL functions. So in this way, all the related project data like the tables, procedures, functions, cursors, or anything else are marked under the same schema, that is LDMS, or the user LDMS. So for the physical modeling design, it's basically adding all this SQL syntax into and actually creating the tables which can be used in the database. So for database, we have used Oracle as a database management system, which is a relational DBMS, and it can be used using with the SQL developer or Oracle Live SQL editor. For the structure query language in Oracle, data definition language, data manipulation language, both are supported. So for this project, I am using the Oracle Express Edition, which is a free version tool for students and educators. It's a pluggable database and it has its own SQL Plus editor where we have actually created a schema. And you can see here, the once Oracle is installed, it gives you the information for the pluggable database, what's the service name, host, and pluggable database SID. So this information can then be used in a tool called a SQL Developer, which is a free and integrated tool. Here, let me show you the SQL Developer where I have connected the local motorcycle dealership. You can see all the tables that have been created using the DDL statements. You can see here the DDL statement for the vehicle model. And similarly, we have created the functions. Functions can also be identified here under the functions tab, and these functions are used basically for identifying the primary key from the original tables and using it as the is the foreign key in later during inserting the data into tables like customer history or the loan table. So once if you see here in the customer table, for example, we are inserting the data, and then we will basically use that data in customer history table to identify the customer's unique ID. So in this way, we are inserting or modifying the data using functions for room keys and using insert SQL statements for inserting the data into the table. Now for data view, you can see here, if you run the select star from vehicle model query, you can see all the data that is available for that particular for various vehicle models. And further, we can go over the reports. For example, the reports are basically the complex queries that have been identified to use for various purposes. For example, the report one here uses a complex query to identify which all customers have bought a Honda Activa, and and we can get all these details. So here we are using an inner join SQL set function with the from vehicle to vehicle model, and similarly we are using the customer and order details table to identify who all customers have ordered that particular vehicle. Similarly, we can identify the booking date and the amount paid, that is sales for a particular date, how much sales has been performed using this query. So if I run this query, we can get the information on the third of April. In the month of March, the sales is 140K. In the month of April, the sales is 200K. So this is how the Oracle DBMS has been used, as we have covered all these features. So count, max, and sum are some of the aggregate functions which can be used to identify information on the number of customers or the sales performed. For mock user interface, we are using the tool called Wufoo, which is a web-based tool. And here you can see the mock screens for adding the vehicle to the inventory, whether it is a new or used. And further information can be added on press of the next, like for example here the last owner's address. So that's how the whole project has been done, where Oracle DBMS is our original main tool for setting up as a database management system. And then we have the Wufoo for mockup screens and SQL developer that helps us to go through all the data views, procedures, functions. Thank you.